提醒他们一下。
现在提醒。
好，那
用给他看。
Moodle。
对，我现在用Moodle给他看。
好，
谢谢。Here, this one. For the homework demonstration. This one.
他是要重新登对，然后到这个。最下面有一个 demo 时间，这个。
Okay. So please visit the Moodle, and we have a demonstration time. So the demo should be next Wednesday, but before that one, before next Tuesday by noon. Okay, by noon, you need to visit the Moodle to register your time, right? To register your time, right?
对，
Right.
中午12点，然后
Before that, you should register your time.
然后我们有 announce 那个可能要往上滑，就是这个 moment day
And here, homework 1,
这个
reminding. Here. Okay. This is the classroom. So in the morning should be at this one in 4263. In the afternoon should be 4202. So this one is upstairs, the other downstairs. Okay. So what's the time for?
就是应该是9点半到12点。对，好，那我再把它标写。
Okay, the morning time is 9:30 to 12. They will update this one for you. Afternoon will be 1:30. Okay, so they will modify this one for you. Okay, thank you for the TA. So be careful. You should go to the Moodle to register your time or the demonstration time. We continue our lecture. 真这样可以哈？好，谢谢。Okay, so we already finished the 3 steps for deep learning, and today we will continue to talk about the why deep learning. So talk about the fact should be deep or wider. The fact, okay. But this lecture is okay. So for this lecture, usually deeper is better. Deeper is better usually. So this is some experience. Okay, so suppose this layer, one layer is meaning one convolution, one activation function. So become one layer. But right now, one layer is one convolution, one batch normalization. Okay, one activation function. So this is one layer. So this 1 layer, 2 layer, until 7 layers. Okay, and this is a parameter size. 2K and 2 layers, 2K. So it's more parameters. So you'll find more layers, but each layer has a 2K cells and more deep, more layers. The result is better. What is error rate? So the result is better. Okay, this is from this paper, but it's very early paper. So this proof deeper is better. Okay. So here the same, deeper is better. And they keep prove it. So the other is if it's fat and short, it's meaning wider, but not so deep. So for example, the same 1 until 7 layers. For each layer is a 2K. Okay, so previously this one. And right now, if we have only 1 layer, but we have a more parameters, it's meaning more cells. It's meaning this one, more fat. More parameters, meaning you have more filters, so it's more fat. This one. Okay. So you'll find out the error rate here. So even though it's fat, but the result is not good. So this one, they try to tell you deeper is better. Okay. But right now, be careful. This is not 100% correct. 我之前把李宏毅老师的讲义把它弄来这里，但是我再跟你讲一下啊，不是李老师错，不是，是因为我是说，基本上这是证明是对的，但是有点旧了啊，所以 too old. So right now is this way. GoogleNet is good one. Go back to here. We back to here, the page 4. In this now is deeper. As Microsoft people say, deeper is better. Oh, that's okay. People at Google say you should a little bit fat. So here is not only not fat and short, no. Here's a little bit fat, but deeper. Still deep, but a little bit fat. That's meaning what? That's meaning you have a one input, but become multiple channels by different kind of filters. For example, in this one, I don't know. Do I have an example or not? I don't have it in this lecture. I don't have this in this lecture. I show you in the other lecture. I use let me check GoogleNet. Oh, I don't have a Google. Sorry, I don't have a GoogleNet. This lecture. 哦，抱歉，我这里没有 Google 东西哈。那我下次再跟你讲一下。那我主要是跟你讲说，我先用口头讲。Okay. That means here is only one direction. One direction, so it's very deep. But GoogleNet doesn't that way. If one, right, it's deep. However, for each input, there are multiple channels. So one filter plus 3 by 3, one filter 5 by 5. So the filter size difference. So the one input will become 4 output and 4 channel, and they merge it together. Okay, and then keep going and divide it by 4. We call multitask. Divide all. We call reception field. They have a different reception field. That's called reception fields. So they have one input and become 4 reception fields and merge together and go in 4 reception fields. So it's not only deep, they're also wider. So the result actually is very good. The problem is complicated. It's not easy to modify. Okay. So back to here. So it should be deep, but sometimes a little bit fat is okay. So it's better result. So GoogleNet is one example. Okay. And the other, we have a ResNet, right? ResNet is one direction, ResNet. But I don't know I saw my ResNet. Let me check my ResNet. Let's see. This ResNet. Let me check my ResNet. See, oh, okay, I have it. See, this is a Google. See, is a one input by multiple channel, multiple reception field. So this is a input here, but up to here is not only dip. Remember, it dip. It is dip, but also they have a wider. It means they have a different reception fields. 就 reception field 就是你看得到的这个领域，所以它变宽了。So this is good. Okay. So see, this is one input but have multiple reception, more reception fields. So this is good. This is good one. They call inception. The other one is the same. Suppose this is a ResNet, bottleneck ResNet. But the other rest next, the wider. So rest next has a better result than ResNet, okay? Because it's have a more reception field. But why people still use ResNet? Sometimes we don't use this one. Sometimes they use, but sometimes they don't use this one. Why? Because it's getting complicated. See, ResNet here. But why right now most people still use this one? Actually, ResNet has a better result than ResNet. Why people don't use this one? Most of the time is because it's getting complicated. And this is a simple. 有时候只是因为你太复杂 it's not easy to modify. It's not easy to modify. So I can modify, so I don't use complicated one. I use a simple one because later on I can modify easier. Okay, so let's tell you this way. So back to original. So the one issue. Okay, so deeper is better. Okay, but sometimes we have a wider, more reception field is better. Okay, that's good. The second issue is if you don't have enough data for training. Suppose in this case, I want to classify the girl and the boy and long hair, short hair, 4 classes. If you want to classify more classes, that's meaning you need to collect more data because they have more parameters. But if I don't have enough data, what I can do is do this way. First of all, you just classify 2 classes. My purpose is classify to 4 classes. But if I don't have enough data, so what I can do, I can try this way. I only classify to 2 classes in the beginning. So the same model, the same training data, but the output difference. So the same model, the same training data, I just classify. First of all, boy or girl, 2 classes. The same model, the same training data, but output difference. The second is I classify to longer hair or short hair. So only 2 class. Okay. And then after this one, let's say for the modeling. And after this one, if I input 1, they have a higher value is boy. Higher value is long. So that means long hair and boy. Okay. So remember, sometimes if the data is not enough, don't try to classify multiple classes. You can try to reduce your classification result. So that's meaning you will reduce your classification classes, okay? And then do the second stage, step by step. Or like this one, you can just use deep learning just for 2 classes. One is for this one, the other is for long and short. And then based on the result, do combination. But the combination, nothing about the deep learning. The combination just based on the confidence value of here. So you can do an integration here, okay? So that's the other method to do if you don't have enough data. So let's talk about this one. This concept. So final one, we will teach you the code. We call hello world. Usually when we do the programming, we will talk about use this hello world to be an example. So this is an example. Okay. So this input, we have 3 output. You want to recognize or classify the digit 0, 1, 2 until 9. So we have 10 classes. And the handwriting. So this wrong. This should be this wrong. Should be 0, 1, 2, 3. Okay. And here, about how many convolutions or how many layers? It's 1 layer. 1 layer include convolution, downsampling. Usually we don't count downsampling to be one layer. We don't. Okay. So this 1 layer. Second layer is a convolution and downsampling. So here, for the net is 1 convolution, 2 convolution, only 2 convolution, and the other 3 is for classification. This is a NLP, the traditional neural network. So we call the net called the net 5 is because there are 2 plus 3, so we call the net 5. Okay, and this is one example, a simple example. Okay, is suppose the 2 input image is 280 by 280. So there's a small page. And here's the first layer is 500 cells. Second layer has 500 cells. And our output is 0 to 9. So 10 classes. So before the output, we will do Somax. So this is a very simple example. Okay. So first of all, this model is sequential. Okay. And we use dense. Dense is fully connected. We connect all of them. It's dense. So the input is 28 by 28. This is too dark. Okay. So input is input 28 by 28. And output is dimension 500. So output is this output 500. And the activation function for each convolution, we use sigmoid. Okay, but that's all the method. Right now, sigmoid most of the time only apply on the final output. Okay, but between each convolution, we don't use sigmoid. We use the ReLU or something like a liquid ReLU, something like ReLU things. Okay, so this is the first layer. And the second layer, because here already have 500, you write 500 output, so that means that 500. And then we are the other, we already have 500 here. So next one, we are the other output 500. So we write 500 here. So dimension 500. The same, you use the sigmoid to be the activation function. And final output is 10 classes uses Somax. So the coding is easy. So that's a topology here. That's a topology for this one. So you set up this one, it's meaning all the parameters has no value. It's empty, no value inside here. Okay. And then second one, we will try to learn based on your data. So what kind of loss function we will use? So loss function we will use mean square error in this case. But this is not good because this is a classification for 10 classes. So it's not good to use MSE. It's better use cross entropy. So this example has some problems, not so good. So it's better because the two classes. If you do the bounding box to do the regression, to do the continue, you use the mean square error. That's for regression, for continue. But this is for classification. It's discrete, so it's better use cross entropy. Okay, and what's your attenuation method? Use the SGD, stochastic gradient descent. SGD, and your learning rate is 0.1. So you set up this here. So this is for second learning target. And you want to measure is the accuracy. Okay. But the learning rate 0.1 actually is very high. So usually we use a 0.01 in the beginning and the 0.40, 0.0001 in the after 10 epoch, you reduce the learning rate. Okay, so the second one. And the final one, okay, is we start to do learning. Sorry, here is I'm sorry. Here is choose the loss function. So they choose the mean square error, but I say you should choose the cross entropy. And learning is choose the learning should stochastic gradient descent, then learning 0.1 and do the accuracy. So the learning rate is 0.1. That's learning. Okay. And then for step 2, what's your data? Your training data here. Your labeling data is here. It's a fit. So this is your training data. You collect training data. This is your label data here. And this is your batch size. So a batch size in this example, they give 100. My experience, that doesn't mean 100 is not good, but most of cases we don't use 100 too many. But some cases use this one. So depends. But because it's mini batch, remember it's mini batch. Mini batch will consider the mean value, the standard deviation. So mini batch size is too small, it's not good. So it's better. My student experience is better than 10. Small mini batch is too small. Size of mini batch is not good. Okay, and number of epoch is 20. Oh, it's fine. Okay, usually 20 is sometimes like 20, but sometimes actually more like 50. Okay. So this is the same. So this is the training data, and this labeling here. Okay. And this explain to you. This is the batch size, and this is how many epoch you want to have. Remember, one epoch include many iterations, so be careful about that one. And so this you finish the deep learning. And after deep learning, the topology you want to set up the inference for inference. So we will start to do test data. So you evaluate your test data. Okay, and you try to find the score one. This on score 1. So that's meaning we want to get this one. So that's your homework. So remember, both figures are important because we cannot see the gradient descent that kind of very high 1 million dimension. We cannot see. So only we can see is this one. This is what we can see. So one is for accuracy, the other is for epoch, number of epoch. So the accuracy and this epoch here, this one is loss. Okay, but if you use cross entropy, it's fine because cross entropy usually is between like a like close to the 0. But when you use the mean square error, actually this value is very diverse. Mean square error 这个会很 diverse 这样子。好，那这个注意一下，这个 so if like this one, actually if the aperture is 50 is not good because up to here they already very stable. So most of the time in this case I can stop. We call early stop around 10 aperture I can stop, because if you have a more aperture, it will be cause the overfitting. So this is not good. Okay, so be careful, and this is very important. So when like my student, when you got a result, I would like to see this result, because sometimes you are do a lot of overfitting problems. In this lecture, okay, so that's it for the initial, this one, what the deep learning network design. Okay, so after this one, I will teach you the based on the paper, but in undergraduate class, I will teach them the other lecture, how to design. But in this class, I don't teach you that one. I show you the difference. So, but I put all my lecture on the YouTube, but you can try to watch by yourself. Okay. But for the, let's see here. Yes. Okay. For undergraduate class, I continue to teach them here, and here is this one. When you after we have a topology, after we training, right, and we not after we have topology, we do training. But if the training based on those two figures, if the training is not good, the result is not good, and how can you improve this one? So I will tell you, you can use those approach, also 5 approach to solve the training problems. Okay, and after your training is getting better or is good, and then for the test, how can, if a test result is not good, how can I solve it? Most of them are overfitting problems. Okay, so I tell you how to solve the test problems. Okay, but in this class, I do not teach you this one. So, but this is important. And if you want to learn this one, you can go to YouTube or just audit at the other class for undergraduate. So I'll teach you this one. Okay. So back to here. So for this class, I will start to teach you based on the paper. Okay, so the first one I will teach you is a Lene. Okay, I always use a simple but important example to teach you, but don't use Lene. It's a bit too old and not so good, but it's easy to teach. So I will start to teach you Lene in this class. I stop this one.